Hello guys, this is Mr. Election and this is SS1 class. I'm so happy to be back here. I believe you're working at home, solving questions, practicing assignment questions, and I believe you've finished your CPT questions by now. So we'll continue from where we stopped the last class. And the last class we discussed about deductive proof. We discussed the sum of angles in a triangle. Sum of angles in a triangle, that is the sum of angles in a triangle is a what? 180. We all know a triangle has 30 sides and 3 interior angles. Let's say we have an angle A, B, C that makes up of a triangle. The sum of what A, B, C will give you what 180. And we also talked about the relationship of a triangle and a straight line. We were able to detect or deduce that we have exterior angles and what interior angles. We all know the sum of interior angles is equals to 180. So an exterior angles are what are the edges of the what interior, like an extension angles, and the sum of angles on the straight line is what 180. We also talked about a transversal line crossing or cutting two parallel lines. It makes an angle at the point of what intersection. And we discussed about corresponding angles. The angles at the same point at the different what parallel lines, and alternate angles, the opposite what angles. So we talk about the properties of parallelogram and properties of what intercept theorem. That's that about that, and I gave an assignment. I believe you've done it by now. So in today's week topic, we'll be looking at statistics, something you're familiar with. I'll just take you through it. We're going to be looking at in two sections, because we are looking at data on group data and group data. Well, on group data, these are the ways we'll be looking at the statistics, because on group data is different from group data. On group data, the data that deals with the exact value of the information, exact value. While group data is what about ranges. You range of value from, like, say 1 to 10, 2 to 15. So just ranges. But we'll be looking at the group data. We'll start with that, and then in the following class we'll look at what the group data. So before I continue, I'd like to share with you our notes so we can go from there and the lesson objective. I'd like to share with you the notes and the lesson objective. So week 6, we're in week 6, X1, statistics. So what we're focusing on this week is the on group data. So this is our learning objective. At the end of the lesson, students should be able to define frequency table. What is a frequency table? How does it look? So we'll be looking at that. How to present data in a frequency table, frequency distribution table, and define main, median, mode of on group data. We are all familiar with these things. So I would like to just do a revision with us and put us through once again. So find the main, median, mode of what on group what data. I can say we're specifying what on group data, because there's another type of data which is called the group data that we'll look at. So this one we just focus on the what on group data. I believe most of you is the first time you're hearing it, and if you heard it before, good. So we can continue from there. So what is the data? Let's look at the data. These are numerical facts. They're just say information. So information you're trying to we are dealing with. These are the data collected. You can say probably if you're born when we have a census, probably if you taught in your other courses that what about census, like collection of like the number of people living in this area, the total number of people in a country, probably the number of students in a class. These are data. You collect those data. As you have your register. How many students are in school today? These are just what we call information data. They are numerical facts or information which can be measured or given numerical qualification that can be analyzed numerically. So when data are collected, there's a purpose why data are collected. The purpose of collection of data is to be able to give a interpretation to the information collected. We don't just collect data for for just to be there. We collect them for to be able to interpret the information. For instance, the census that want to look at how many people live in this area. That's why we'll go house to house to look at how many people are here, how many people are here, how many people, in case you want to make a provision for that environment, you look at the numbers of people there, then you know how to quantify what the provisions you are making for the environment. So when data are collected, current interpretation must be given to them, so that the information collected may be correctly used for whatever purpose it was collected. That is, you don't just collect information, there has to be a purpose for it, and you have to be able to interpret every data. Data collection involves gathering of variables. Gathering of variables. It could be age, it could be numbers, it could be height. It's a collection of variables collected. Let's say we are coming to the class now. How many students offering the variables there in the class? How many students are offering economics? You look at those variables are Greek. You look at biology, mathematics. So it involves gathering of variables. So what are variables? Variables are event or occurrence that may take what different value. They are event or occurrence that may take what different value, like the height of students in the class. It could be what the height of this one is 5.1, 5.2, 4.3. So the height of the ages of students, the weight of certain people in the gathering, the marks of an examination, or the volume. So these are the variables. These are events or occurrences that may what take different values. So that's the basics of where we are going to. You have to know what data is and why they are what collected. It has to be what for the purpose of what interpretation of what information. So we look at the next slide. Now variables are divided into two parts. We have the discrete variables and the continuous variable. The discrete variable, they take the exact values. That is, they take the exact value, the exact number we're dealing with. Unlike the continuous variable, those ones deal with infinite what numbers of value. That is the range between what two fixed points on the scale. The range from, let's say, 1 to 10. For example, in a class now, we want to look at probably the ages of students ranges from what 10 to 20 years old. Like from 10 years old, the least person is 10 years old, and the oldest person is 20 years old. Then we want to look at that. In case of discrete variable, we take it one after the other. That's why they say they take exact value. You look at how many students are 10 years old here? Probably 2. How many students are 11 years old? Probably 4. How many students are 13 years old? Probably 5. How many students are 14 years old? Probably 6. Then till you get to the what oldest age. But unlike continuous variable, you can gather information from 10 to 13. How many students are falls within this range? Let's say 10. From 14 to 15, 14 to 16. And it has to be at a what a regular interval. The difference between the interval has to be what the same or true. I say 10 to 13, that's like 10 to 12, that's like 10 to 12, 13 to 15, 16 to 18. It's a comparison of what infinite what numbers of value, unlike discrete value, that is, it deals with what the exact what value. So the difference between the what continuous and variable is this: that this discrete variable takes the exact value, usually all numbers. They are obtained by counting, e.g., the number of students offering what economics. It's not the number of students offering economics and biology together, or the number of students offering economics, biology, and mathematics. No. Why continuous variable are those that take infinite numbers of value between what two fixed points on the scale. That is the lowest to the what highest. If I'm taking a range of 10 to 13 ages in a class, so the lowest fixed point is what 10, and the other fixed point, the highest fixed point is what 13. That's why they said between two fixed points on the what on the scale. So let's go to frequency table. So this is where we start from. Our frequency table shows the number of occurrence, shows the number of time an event or a variable what occurs in a given what information. The number of times an event or a data occurs in a given what information. That's why you have a frequency table. When you have your variables, how many times does this variable occurs? How many times does this occurs? That's why you prepare your what frequency table, and it makes it easy to interpret what information. If you are giving the raw data, I believe we know what raw data is. And it's a collection of data that are randomly arranged. And I want you to know something. The purpose of frequency table is to what? Get the orderly arrangement of what? Of data. Because when you are giving a raw data, they are randomly arranged, they are what scattered. So frequency table shows the number of times a particular event what occurs in a given information. Number one, look at this. Frequency table usually contains 3 columns. It contains what? 3 columns. First, the first column consists of the event given in the data. The event, the occurrence we are dealing with, that takes the first column. You know what column is? 1, 2, and 3. So the first column gives the information of the event we are talking about, the event in question, the information in question, and they are normally arranged in what ascending order. I believe you know what ascending order is. That is in an increasing pattern. We have 2 types of order. We have the ascending order, and the opposite is what? Descending order. In case you have a scattered number, like let's say ranges from 1 to 10, you have 10, 7, 6, 5, 3, 1, 4. You can see they are not arranged they are arranged randomly. So if you want to arrange it in an ascending order, you don't start from, it ranges from 1 to 10, they start from the lowest number down to the highest. 1, 2, 3, in an increasing manner till you get to the what? Highest. But in descending order, you start from the what? Highest down to the lowest. That's in a decreasing pattern. So that talks about the first what? Column. The second column is used to make strokes. We call it the tally column. I believe you are familiar with what we call tally. Tally is called the what? Tally column, whereby you start counting the number of times the variable occurs and the number of occurrence of the variable. Let's say 5. You strike it what? 1, 2, 3, 4, and every fifth stroke is crossed across the what? The 4 strokes. Every fifth stroke is called across the what? The 4 strokes to form a what? A bundle. A bundle is made up of what? 5 strokes. If you have 3, so strike 1, 2, 3. If you have 7, you strike 1, 2, 3, 4. The 5th goes across it to make it what? 1 bundle, and that's 5 strokes. Then you continue again, 1, 2. So add it together, it gives us what? 7. So the second column is used to make strokes which represent the number of times a particular event occurs or appear. This is where I am. Number of times a particular event occurs or appear. After the first stroke, the 5th one is written across the 4th to give a bundle of what? 5 strokes. That's why I said earlier that after the first stroke, you strike the what? The 5th across the what? The 4 strokes to give you what? A bundle. Let's take an example. Okay, let's take the third column. So the third column is obtaining by adding the number of what? Strokes in the second what? Column together. Adding the number of strokes in the what? Tally column to what? Together. After you've gotten your strokes, if it's 3 strokes, then you write it out 3. If it's 7, as this 1 bundle and 2 strokes, you write it out 7. If it's 2 bundle, you write it out 10. If it's 3 bundle, you write it out 15. Always know that a bundle is made up of 5 stroke, and the bundle is written as 4 stroke, and the 5th stroke is what? Strike across it. Let's take this example. Looking at this example now, look at this. I told you earlier that we have raw data. This is a raw data. I can see the lowest number here is 11, and the highest number is 16. This is the highest number, 16. But they are not arranged in a what? In an orderly manner. I told you we can arrange it either in an ascending order or a descending order. But they are not arranged well at all. So we call them raw data because they are what? Randomly arranged. A teacher provides the age of 32 students in the class 3 of a junior secondary school. Let's say this is a JS3 class, and their age ranges from what? 11 years old to 16 years old. Now, how do you now calculate? How do you interpret this information? This is a real data. It is not easily you cannot easily interpret this or provide what or purpose for this what information to be very rare. That's why we have what? A frequency table. So we asked to prepare a frequency table for this information now. So I told you we have what? 3 columns in our frequency table. We have what? Events. What's your variable you're looking at? The second column is the tally column, and the third column is what? Is the frequency column. So this is the solution. This is how your column will look like. This is how the column will look like. You can see the variable first in the first column, and the tally column, and the frequency what column. So how do you get this information? Start from the what? I told you the first column, you start from the what? You arrange in what? In an ascending order. You arrange in a what? Ascending order. That is from the lowest down to the highest. The lowest age is what? 11, and the highest age is what? 16. So how many levels do we have there? Then start counting. You have to count. And I told you, and the discrete variable, this was what? Counting the exact values. So now look at it. 11 is 1 year. 2. We have 3. You have to take it gradually so you don't miss any point out. So we have about 3 levels. And so we have striking the strokes 1, 2, 3. Then you write the frequency out 3. For 12, we have 1, 2, 3, 4, 5, 6, and 7. There's 1, 2, 3, 4, 5, 6, and what? 7. So we have what? 7 strokes. So we have what? 1, 2, 3, 4. 5th one, I told you, you strike it, your 4 strokes to give you 1 bundle. So we have what? 1 bundle and what? 2 strokes, giving what? 7. So you guys have 7. If you look at the 13, to give you the same thing, we have 7 there. 13 is what? 1, 2, 3, 4, 5, 6, and what? 7. It's 7 what? So you have what? Now strike it. 1, 2, 3, 4. Strike the 5th one to give you 1 bundle and 2. If you look at 14, we have what? 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. So that gives you what? How many bundles? That gives you what? 2 bundles automatically. That's 1, 2, 3, 4, 5. 1, 2, 3, 4, 5. So if you count all this together, you do that for 15 and 16. Count all this together. You have what? 3 plus 7, that's 10. 10 plus 7, that's 17. 17 plus 10 is 27. 27 plus 4 is 31. And 31 plus 1 is what? 32. And according to the question, we have how many students? We have 32 students. So it is easy for you to now interpret this information from this what? Frequency table. It is easy to get the number of 13 students. The students that we have at age 13, they are 7 students. The student with what? Age 14, they are 10 students. The student with age 15, they are what? 4 students. So it is easy when you prepare your frequency table, information are what easily what are gathered, and it is easy to interpret the data what collected. Look at it now. The above data, their data above is what? On group data. This is because the entry is recorded on what? On its own, individually. If we are not looking at range for probably 11 to 12, then we'll be having like 10, 13 to 14, we'll be having like 17. No, it is, we take the ages what? one after the other. We'll check the ages what one after the other. I believe you understand this. That is a frequency table as what 3 columns. First one, the variable column. This is the first column. And the second one, the tally column. And you know how to prepare your tally. They have 4 stroke. The fifth stroke what course across it, and you write what the out, the what count the strokes out, and write it out in numbers and what the frequency what column, the frequency column. And this is an what on group data we talk about. I told you that this is what exact what value. So we'll go to the calculation of what mean, median, and mode of what on group data. Mean, median, and mode of what on group data. I know it's something you're familiar with, but we'll just go through it gradually for better understanding. So first, we'll take the mean. When we talk about the mean, you know that the mean is the sum of what all the collection of what data divided by the number of what the number of data collected. All the collection of the sum of all the what collection of data divided by the what the number of what data are collected. That is the arithmetic mean of ungroup data can be calculated thus. Given a set of items, let's say x1, x2, x3, x4 down to xn, we can find the arithmetic mean denoted by what x to what x1 plus x2 plus x3 plus x4 down to xn divided by what the number. That is the number of this. It could be 15, then it's what 15 numbers. It could be 20, it could be what 20 numbers. But I have a number like let's say 1 to 4. But I'm asked to find the arithmetic mean. It will be what how many numbers do we have? 1, 2, 3, 4. There are 4 numbers. There are 4 numbers. Doesn't mean I'm saying 1 to 4. You can do like let's say 20, 30, 60, and 80. We have 20, 30, 60, and 80. They are what 4 numbers. So it will be what the arithmetic will be what the sum of all the numbers divided the number of the what numbers. That is 20 plus 30 plus 60 plus 80 divided by what 4. Divided by what 4 because I have what 4 numbers. So that is how to calculate what the arithmetic mean. But furthermore, sometimes when the numbers of item is large, we can have what a larger numbers and not just numbers you can just easily count. So when the number is large, there will be need to form a frequency table. I already told you how to prepare your frequency table. So the frequency table we have 3 columns: the item columns, the frequency column, and the column for the product of what item and its respective what frequency. That is the item column, the numbers we are looking at, the frequency, how many times they occur, and the product of what the number of the variable we are dealing with, and the number of their frequency, the product. So you get to what the frequency table. I will explain that in the. Let me explain that with this example. Look at this example now. This is the raw data. So the collection of raw data. Calculate the mean of this what of the student. The following are the marks scored by 50 students. You can see 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. 1, 2, 3, 4. These are 50 marks for what? 50 students. These are the marks for 50 students. So what's the list number here? The list number is 12, and the highest number is what? 30. Highest number is what? 30. The first column in preparing for your mean, preparing your frequency table is what? Now write out the variables down. How many times does 12 occur? You write out the frequency, and now find the product of the what of the two. Like I said here, it has what 3 columns. Calculating the mean, we have 3 columns: the item column, yes, or the numbers, the frequency column, the number of occurrence, and the product of the what the item and the what the frequency. You multiply what the item times what the number of what occurrence. So this is it. So let's go to the solution. You can see we have 12, which is the list number, down to the what 30. 12 occurs 16 times. Let's cross check. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, and 16. That's correct. So 12 occurs 16 times. This one is the first what? The first tally, first column, the item column. Number 2, it occurs 16 times. 12 times 16 will give you what? Fx. So mark is represented as what? X. Frequency is represented as what? F. So the product is what? F times X, which is what? Fx. So 12 times 16 will give you what? 192. Please, I want you to get your calculator to what? Follow the details. So 15 occurs what? 13 times. If you multiply this way, you get 195. You have to construct that too. 20 times 99 will give 180. So we add all things together. 16 plus 13 plus 9 plus 5 plus 7 will give what? 50. To what? Construct the question. Because that's to what? Match the what? Total number of what are given in the what? In the question. So we have 50. And the product, the sum of all this is what given as what? 902. So in calculating a frequency, arithmetic mean in frequency table is the sum. This is a summation. We call it summation. Is the sum of the product of the frequency and the mark. The sum of the product of the what? Frequency and the mark divided by the sum of the what? Frequency. Arithmetic mean, in case you have a larger number, I say this is a large number of 50 now. We're looking at the product of 1902. Can be easily dealt with. Probably we're counting 12 plus this now divided by 50 to be a long process. So we are looking at that. Arithmetic mean in dealing with a large number is the sum of the product of the what of the mark and frequency divided by the sum of the what the frequency together. So the sum of the product of this is what 902 divided by what the sum of the frequency, which is what 50. So this is the formula. Arithmetic mean is equals to what x represented as x, sum of the product of the what frequency and the mark over the sum of the what frequency, which is what 902 divided by what 50, which gives us 18.04. You can cross check. If you add all this together, 12 plus 15 plus 20 plus 25, you will see that divided by 50, you see that you get what the same thing. So, but it will be easier using what the frequency table. You can say this will be very, very tedious. 7, 12 plus 5. So that is it. In case you have a large number, this is what we use. So we go to the median. We all know what median means. Median is the number that falls in the middle. And from the name, you can see, let me read the note for you. The median from group data is the value of the middle item when the items are arranged in an order of magnitude, either ascending or descending. What we are talking about, order of magnitude, that is, they are now, before you can find your median, you have to first arrange your what informations properly, either in an ascending order or in a descending order, preferably an ascending order, arrange in an ascending order, then you now find the number that falls in the middle. When the number of items is odd, that's when the number of items is odd. Let's say like 3, we have 1, 2, 3. These are 3 numbers. They are odd numbers. We have 1, 3, 5 as odd number. If you are having odd numbers, the middle number, you always have one middle number. That is, if you have 1, 2, 3, the middle number is 2. It falls in between. If you have 1, 2, 3, 4, 5, that's an odd number 2. The middle number is 3. If you have 1, 2, 3, 4, 5, 7, the middle number is 1, 2, 3, 4, 5, 6. You have a single middle number. But in the case when you have you don't have if the number of items is even, if you have an even number, the arithmetic means you don't have one single number. You have a case of 1, 2, 3, 4. The middle number is 2 and 3. They fall in between. So how do you calculate that? You add the middle numbers together and divide by by 2. You add the 2 middle number and divide by 2. Note, if you're having an odd number, you have one single number that falls in between. But you're having an even number collection of numbers, you have 2 numbers. And how do you find the median of this? You add the 2 numbers together and divide by by 2. If the number of items is even, the arithmetic mean of the 2 individual items gives the median score or value. In the case whereby frequency table is required, the median will be what? In case you want to use a frequency table or prepare a frequency table like this, so you use what? This is the formula to use. Summation f plus 1 divided by 2. Summation f plus 1 divided by 2, where f there is what? The frequency. Where f there is what? The frequency. The median equals summation f plus 1 divided by what? By 2. Where f there is what? Is the frequency. So let us consider this frequency table. To consider this question again, let us find the median for this collection of set of data. Let us find the frequency median for this collection of data. Look at it. So for that question, so the frequency is given as 50. Summation of the frequency is 50. You say 50 plus 1 divided by 2 will give 51 over 2, which will now give you 25.5. But if you want to find the median, you now go to the frequency table. Where does 25.5 falls in between? Now say this is 16. Start adding your frequency table together to get that value you got there. So 16 plus 13 is 29. That is 29 falls, 25.5 falls 16. From 17 to 29 falls in between 15. That is from 1 to 16 falls in the frequency of 12. So from 17 down to 29 falls in between 15. So you have 25.5 will be in 15. So 25.5 will be in the between of 25 and 26. And that falls in 15. So you now say, this is it. From the frequency table, 25.5 falls in between 15 and 15. And 15, it falls between 15 and 15. That is 25, 26. It's still in the range of the mark of 15. So you add the 2 numbers together, 15 plus 15, divided by 2 to give you 15. So the median of this collection of data is 15. So in case you have a larger number like this, you want to prepare a frequency table, how to find your median is summation f plus 1 divided by 2. Summation f plus 1 divided by 2. But in case we have a smaller number, is if it's an odd collection of number, the number in between is the median, and it's an even collection of number, the middle number is the sum of these 2 numbers divided by by 2. Let's look at the mode. We all know what mode is. This is a number that occurs most, that often occurs, that appears most. When the frequency table, we have a frequency table, the number that has the highest frequency is the mode. So that's what mode is all about. And we also have the last one, which is the range. Range is the difference between the highest value and the lowest value. I believe we understand that very, very well. But the easiest way of calculating the mode of any distribution is finding what is to form a frequency table. Look at this example. We all know that the number that appears most is the what the mode. The number that has the highest frequency is the what the mode. So look at this. Look at this example. For a class of 30 students, we have 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. In 3 places, that's 30 students. The score of mathematics, the score on a mathematics test out of 20 are as follows. That is over 20 of 30 students, 8 over 20, 10 over 20. Now, you don't know how to prepare your frequency table. In case you want to use a tally table, you just want to prepare directly. So the least number here is what? 4. And the highest number is 18. This number is what? 4. And the highest number is what? 18. I told you first thing you do here, prepare your first column in the what? In an ascending order. 4, 6, 8, according to what? To the mark given. 4, 6, 8, and according to what? Mark given. So you now start counting. How many times of 4 occur? 1, 2, 3, 4. It occurs what? 4 times. So that's how you do it for the what? All other scores. 6 occurs 3 times, 8 occurs 3 times, 10 occurs 6 times, 12 occurs twice, 14 occurs 7 times, 16 occurs 2 times, 18 occurs 2 times. So the number, the highest frequency is what? 7. The highest frequency is 7. Give me that the mode is what? 14. From the table above, the highest frequency is what? 7, and the corresponding mark is what? 14. Therefore, the mode is what? 14. So this is how to what? Calculate the mean, median, mode, and frequency table for what? On group what? Data. This is how to calculate the mean, median, mode, and frequency table for the what? On group what? Data. So in the next class, we'll be looking at what? Group data, but you have to go back to your online notes. Attached to your online notes, there's an assignment. I prepared like 2 assignments there. I would like you to try. So you all know the difference, how to prepare what? Calculate what? The mean, median, mode, and prepare a frequency table what? For on group data. We have come to the end of class. Thank you for your time. And I want you to please practice all examples solved in this question and solve the assignment, and go further to your textbook to solve what? For the question. Thank you, and have a nice day.